Our sub-driving question is, assuming different layers of material, how does the depth of the material affect the crater size? Okay, we're going to do this by having a pan on the floor and then putting flour in the pan. We're going to start at 1 centimeter and go all the way up to 6 centimeters, increasing by 1 centimeter at a time. Then we're going to take the red Kool-Aid we have down here and just sprinkle it on top of the flour so that when we drop the ball, the crater will be more visible. And we're going to use a golf ball to do this, and we're going to drop it. From 72 inches each time, and then we're going to measure the height and the depth and the width of the crater so that we can compare them.
And now we're going to measure it. This is very messy science. So Shannon and I were talking about this, and our follow-up question as we were going through the experiment was going to be, what if you change the material? How would that change the measurements? So we talked about, well, what if we use sugar? So that maybe give us very different results than what the flour is giving us. But also, this is something we didn't expect. With this last one, there's some good explosive flour going on here. You can really see this is the first time where it's really come out to the side, and you can even see it on the back wall here, how it really just poof exploded up. So there could be something going on, a different phenomenon here with the displacement of the flour given the depth. So that could also be another good follow-up question. Does the depth of the flour affect the explosiveness of the impact?
So as Shannon and I were doing our data analysis, we clearly saw some steady increases in both the width and the depth of the craters. We do think that this would level off in both of them. The depth of the crater is going to level off because even if we had 200 centimeters depth of flour, there's only so much kinetic energy that our golf ball is going to have dropping from 6 feet. So eventually that one would have to level off. Also, the width of the crater is going to have to level off because the golf ball is only so wide. It's actually 4.26 centimeters wide, and eventually that is going to have to level off as well unless we start putting more kinetic energy into the golf ball for each impact. Shannon and I also looked at a change in the width and the depths of the craters from trial to trial. So there's only 5 of these comparisons compared to our 6 trials. But what we noticed is that with the change in depth, there was no clear pattern that we could establish out of this. one reason for this is we did use the same flour that was already there from trial to trial. So the 1 centimeter flour from trial 1 we left in there, just poured new flour over and repeated for trial 2, left that flour in, repeated for trial 3 with more flour, etc. And it's possible that our previous craters were compacting the flour and not giving us accurate reflections in the changes in depth. That may be one possibility to explain why there's no clear pattern here, or maybe scientifically there is no pattern here. Maybe this is a chaotic phenomenon. With the change in width, that definitely did show the pattern, and just like we were saying earlier, this one is leveling off, and there's a neat mathematical extension that you might be able to get out of this. So, to get your students to explore this extension, or if you wanted to explore it yourself, you could look at the drop-off nature of the curve, and you could have your students model it through something called a logistic model, which sometimes it's hard to find applications for that to get students to understand why we actually study those. So you could actually get the students to look at it that way, and then once you look at the rate of change as pictured in this graph, you can then integrate or solve the differential equation and get this type of curve, which fits our data beautifully. And again, this is just a nice way to show the students how you can use logistic models in real life all the time.
Oh!